Okay, USA Today poll asks a random sample of 1,012 U.S. adults, do you drink the milk in your cereal after you're done eating the cereal? And 67% of them said yes, they do. Now they think that it's the proportion of the population is close to 70%. What is the mean of the sampling distribution? Why? That's letter A. Well, we would write it like this. Here's the mean of all of those proportions from many, many samples. And when they get that, the average should be 70%, which is the proportion of the population. So we're going to say that it is the same. Why is it the same? It's an unbiased estimator. There, unbiased estimator. The sample proportion is going to be very close to the population proportion. Now, what is the standard deviation? Well, we did that today. Let's take a look at what that might look like. Move that up here. What was the formula? Here we go. It looks something like this. The standard deviation of the sample proportions is going to be the square root of our proportion times 1 minus the proportion divided by the number in our sample. There you go. So, and what is that? And that is 0.0144. Okay, what's next? The 10% condition. Let's see, where is it? The 10% condition is right. Where is it? So anyway, 10% condition is saying, is the population 10 times bigger than this? So we're really talking about Americans, I guess, in the United States. So it's way bigger than that. So 10% condition is met. 10% condition. Now we talk about what's next? The next one, letter C, is we talk about whether it's normal. That's where we take 70 and multiply it by the sample size. Is that bigger than or equal to 10? And that's a yes. Well, what about the other one? 1 minus the proportion. Is that number bigger than 10? That's also a yes. Okay, there's that. What about D? Well, what do we do for D? Well, that is a z-score. I'm just going to set this one up for you. So it's the z-score, right, is equal to the number we're interested in, which is 0.67 minus the mean of our distribution divided by our standard deviation. And we do that number and normal CDF and see what we get, and we figure out how likely is that to happen. Okay, is that kind of weird or is it not weird? You do that and figure it out. Okay, let's do the next one. So 37 is saying, how could we get this standard deviation to be half as big? This right there. Well, to decrease the standard deviation, we have to increase the number on our sample. But I could solve this using algebra. 0.0144. No, half of that is going to be 0.0072 is equal to, let's see, 0.7 times 0.3, and just figure out what n is. So you try that problem. Hey, I forgot about this one. The Hispanic worker problem. Now, they say up here, don't forget, you got to look up here to see what are they asking you to do. Why does this not work? So, over here, 30% Hispanic. Well, if you take 0.3, actually, let me write it down. So, if you check it, you would have to take, so for our approximately normal population, we would say 0.3 times 15. That is not going to be bigger than or equal to 10. Not Okay, so it doesn't work. That's what the problem is. It's really not approximately normal, so we should stop right there. Okay. Okay, on this one, on time shipping, I want you to try this one on your own, but I will give you a head start here. So 90%, we're going to say that it's an unbiased estimator. So how do we write it? We say what? So the mean of the sampling distribution of proportions is equal to the population proportion, which is 0.9, like that. Okay, and then they say they take 100 and 86 of those orders were on time. So our p hat from our sample is going to be 0.86. Okay, that should get you started, and you're going to get, let's see, what? Standard deviation, and you got to check the 10% rule, and then you're going to see if it's approximately normal, all that stuff. And then, in the end, guess what? You are going to do a z-score, okay, to figure out the rest of it. And then this is kind of where you say, well, is it weird or is it not weird? Okay, you guys try that one, and I will see you tomorrow.